Hello and good morning, dear students. So today is 3rd of August, and yes, in the last class we were doing exercise 8.18 and we were doing according to the properties. Okay, so we started with property 4 and 2 classes we have done property 4, and now today we'll do property 4 1 or 2 sums, and then we'll move to property 3. Okay, so this question, that is question number 22, is also based on property number 4. Okay, let's read the question. We have to show that, okay, first the question says if a function is continuous in close 0 to a, then show that this is equals to a by 2. Already given the function is continuous, we have to prove that this integral is equals to a by 2, and we are going to use property 4 out here. Okay, so this is a function 0 to a fx divided by fx plus a minus x dx. Okay, and we have to prove it as a by 2. Now the first step is same. Assume this integral as capital I. So this integral as capital I. Okay, keep it equation number 1. Okay, now we use property 4. So by property 4, capital I is equals to 0 to a remains as 0 to a, but wherever it is x, it will be upper limit minus x. So a minus x, a minus x, and we put x equals to a minus x, a gets cancelled out, so we get fx. Okay, remember that we have done the first day when we started property 4 sums. We have taken 2 equations and adding the same thing we are repeating out here. Okay, equation 1, equation 2. So adding equation 1 and 2, left hand side if you add you'll get 2i. Right hand side if you add, we know this and dx is common, so this and dx common, so inside the box bracket this expression plus this expression. Okay, now you can also see the denominator is same, so the LCM is same, isn't it? So the numerator will be this, where this and this gets cancelled out, so therefore I will be getting 2i is equals to 0 to a dx. Okay, and now it's simple. Integration of dx is x, 0 to a, upper limit minus, and then 2i equals to this, so I equals to a by 2. Okay, very simple question. Question number 22 part 2 is also same, that you will be doing yourself. Okay, so pause the video and note it down. Okay, let us proceed. Now I'm starting with question number 21. Now in question number 21 there are 4 sums, and all these 4 sums we have to do by using property number 3. So once again quickly let's go back to property 3. The previous one was property 4 and this one is property number 3. So what is the property number 3? Integration of a to b fx dx. Integration of a to b fx dx is equals to integration of a to b upper limit plus lower limit minus x. Now in the previous one was just upper limit minus x, right? But here you have to add both the limits and then minus x. That's the only difference. Property 4, upper limit minus x. Here sum of 2 limits minus x. Okay, now focus out here. This is the given question to us. You can see now lower limit is not 0, lower limit is 2 to 3, and this is the function given to us. What is 2 plus 3? 5, and you can see 5 also out here, so it is going to be easy for us. The first step is very same. Assumption. Assume this given as capital I, keep it as equation number 1. Now what we'll do is we'll use property number 3. So by property 3, see the limits remain same, so 2 to 3 remains as 2 to 3, but wherever it is x, it will be upper sum of the limits minus x. Wherever it is x, it will be sum of the limits. What is the sum of limits? 2 plus 3, that is 5, so 5 minus x. I hope you're getting this. Similarly, wherever it is x, it will be sum of the limits, that is 2 plus 3, 5, 5 minus x, plus wherever it is x, it is 5 minus x. So minus 5 plus 5 gets cancelled out, so hence it will only be x and then dx. So is it very simple again? So now what to do? Keep it as equation 2. What will I do now? Adding 1 and 2. So you can see the denominator is same. Root x, 5 minus x, 5 minus x, and 5 minus x root x. So again you know what to do. Take the LCM, gets cancelled out. Very simple. Okay, I'm going to show the steps. Pause the video, note it down. Alright, so therefore this is equation number 1, equation number 2. Now what we are doing is we are adding equation 1 and 2. Left hand side if we add 2i, and right hand side you know this and dx is common, so I have kept common outside, okay, and this expression plus this expression is this. Now can you see the common thing out here? Root x, root 5 minus x, root 5 minus x. So hence the LCM is same. So numerator will be this plus this, which is same. This and this cancel out. So therefore 2i is equals to 2 to 3 dx. And now it is very simple. You can understand. So in this way, property 3 also works. But please be clear. The limit has to be from a to b, not from 0 to a. Okay, if it is 0 to a, property 4. If it is 2 to 3, property number, a to b, property number 3. Okay, pause the video, note it down. Alright, so next one, 21 part 2, a similar type of question. Assume the given integral as capital I, keep it equation number 1. You can see the limits 2 to 8, so hence I have to use property 3. So therefore by property 3, the limits remain same. Sorry, this is 8. This is 8. So 2 to 8. So now what happens is wherever it is x, it will be sum of the limits minus x. Okay, so what is your sum of the limits? 10. So 10 plus 1, 11. So 11 minus x. Wherever it is x, it will be actually 10 minus x, isn't it? But since plus 1 is also there, so 11 minus x. X, 11 minus x. And x, 11 minus x. So 11 cancel out. So only x. So again the same thing. Two equations you add. So while adding you get 2i, and now I don't have to tell you, everything is same, it gets cancelled out. So 8 minus 2 is 6, so 2i equals to 6, so I equals to 3. Okay, very simple, don't take it very, it is difficult. It's very simple. The equation is given to you, apply property 3, you will be getting the denominator same, add, cancel it, finished. Okay, so pause the video, note it down. Alright, so next one I'm taking is question number 21 part 4. Okay, 21 part 4 and 21 part 3 are similar. So once I do part 4, you'll be easily be able to do part 3 also. Okay, the question is I equals to pi by 6 to pi by 3 tan dx by 1 plus tan. Whenever there is denominator 1 plus tan, always make this tan as sine by cos. So when you do sine by cos, take the LCM, it will be cos sine plus cos dx. Keep it as equation 1. Okay, now use I hope you are clear from here to here. Just we are changing tan as sine by cos. So cos come as the numerator and sine plus cos. Okay, so property 3. Now what is property 3 tells us is wherever it is x, it will be of sum of the limits minus x. It will be sum of the limits minus x. So wherever it is x, you can see out here I have put pi by 3 plus pi by 6 minus x, sum of the limits minus x, sum of the limits minus x, sum of the limits minus x. Okay, now to understand more, pi by 3 plus pi by 6, you can see out here, pi by 3 plus pi by 6, if you take the LCM 6, 3 pi by 6, which is pi by 2. So pi by 3 plus pi by 6 is pi by 2. So cos, inside the root, cos, this is pi by 2 minus x, sine pi by 2 minus x, cos pi by 2 minus x. Now what is the formula? So therefore, I is equals to pi by 6 to pi by 3. This is going to be sine x. This is going to be cos x, the complementary angle formula. And this is going to be sine x. The sine 90 minus x is cos x. Cos 90 minus x is sine x. Keep this equation number 2. Now it is very simple. You can see denominator same, numerator also will be same. Everything cancel out. Okay. So adding 1 and 2 will do now. Pause the video, note it down. Alright, so these two equations 1 and 2, if we add 1 and 2, we know I plus I 2i, and this everything gets cancelled out if we add this 2, so I'll be only getting pi by 6 to pi by 3 dx, pi by 6 to pi by 3 dx, which is x. So this is pi by 3 minus pi by 6, pi by 3 minus pi by 6. If you simplify, then you'll be getting pi by 6. So 2 into 6 is 12, hence the answer is pi by 12. The previous question is exactly the same. That will be your assignment. Okay, pause the video, note it down. Alright, so this will be the last sum for today. That is question number 14. Now I'm going to question number 14. Okay, in question number 14, the question says evaluate 0 to 9. By the way, this is 2008, ISA 2008 question. Evaluate integral 0 to 9 fx dx. We need to find the value for this. Where the value for fx is given is in this way. One of the values is sin x, other one is 1, and other one is e to the power x minus 5. And the ranges has been given out here. The value for fx is sin x from 0 to 90, the value for fx is 1 from 90 to 5, and the value for fx is this from 5 to 9. Now see, if you see from here 0 to 9, we are asked to find the value from 0 to 9, and 0 to 9, the interval from 0 to 9 has been divided in 3 intervals. Remember, I've given property 3. What was property 2? A to b fx dx was, I can break the limits, isn't it? A to c fx dx and plus c to b fx dx, where the c must lie in between a and b, isn't it or not? So this was property number 2. So this property number 2 we are going to use out here. So you can write down by property 2, 0 to 9 fx dx. I can write this as, first I'll write from 0 to 90. By property 2, 0 to 9 fx dx, I can write this as 0 to 90 fx dx. Now see, I have to continue from 90 only, 90 to what? 90 to 5 fx dx, very simple. And then from 5 to 9 fx dx. So now it has been completed. Now if you see, it is from 0 to 9. So 0 to 9 I've broken down into 0 to 90, 90 to 5, 5 to 9. Okay, the reason I'm doing this is 0 to 90. From 0 to 90, what is the value for fx? Sin x. So I'll replace the value for fx as sin x. From 90 to 5, the value for fx is 1. So keep it as 1. And 90 to 5. And the last one, from 5 to 9, what is the value for fx? E to the power x minus 5 dx. Now we'll simplify this one by one and we'll find the answer. So pause the video, note it down. Alright, so when you take the integration, you'll be getting integration of sin x is minus cos x, 0 to 90. Integration of x is, dx is x, 90 to 5. And e to the power x minus 5 dx, e to the power x minus 5, 5 to 9. Now what we'll do in the next step, we'll put the upper limit minus lower limit. So pause the video, note it down. Okay, now this step everyone knows it. From here what to do, upper limit minus lower limit, upper limit minus lower, upper limit minus lower. So minus I've taken outside. Okay, by the way, what is cos 90? Cos 90 is 0 and cos 0 is 1. Plus this is 5 minus pi by 2 plus e to the power, this is 4 and minus e to the power 0. By the way, e to the power 0 is 1. Now open the brackets. This is 0 minus and minus plus 1 plus 5 minus pi by 2 plus e to the power 4 minus 1 plus 1 minus 1 cancel out. So the final answer is 5 minus pi by 2 plus e to the power 4. Okay, so this was application of property number 2. So one by one we'll be doing it this way in the later classes as well. So pause the video, note it down. Right, note down your assignments. Your assignments for today will be 13, 21 part 3, 22 part 2. Okay, that's it for today. I'll see you tomorrow in the next one. Thank you.